nüüd kuradi. Ma tõmban momenti hinge. Ma proovin oma peas muuta testi tööle panna. Kumb ka selline, kas parameetri, kas tüüp või nimi ja tüüp, kooloniga ilma.
Kotlin läheb auga, kusjuures me vaatasime Germaniga, et see Fushi ja whatever selle nimi on, aga selle nime nad muudavad üle.
Fuksi, jah?
See, mis tuleb ka nice.
That's nice, jah. Aga millal see Fuksi ükskord tuleb? On see Fuksi kirjutanud mingi 6 aastat pärast või?
See on oma näite küsimus.
Jah, nagu ops-üssi kirjutamine ei ole nagu kerge ettevõtmine, teeb mis tahab. Võtame naera. Nii, salvestuses ka käima. All right. So, let's start. There should be 250 of you or something. So, palju teid on nüüd? 30 enam täis ei saa. 250 või midagi. Oleme graafikus täiesti, jah. Ei, no mul on nagu alati, et ma nagu semestri alguses broneerin terve korruse ja siis nagu 3. loengust alates mul enam neid ruume vaja ei ole, et nagu võib keegi teine tulla siia midagi tegema. No näe, rahvustamata tuleb. All right. So, let's start. So, last time, hopefully everybody watched the JSON practice from the previous daytime lecture. So now we slowly start to move into more complex territory. And now we want to save our stuff to the database. So this is only kind of easy and simple introduction into the databases. You currently are taking the database course, I think, yes? So now you can actually use your knowledge and try to wrap the head around how to design the databases and how to actually save something. So even before you get too far with your game brain or your game business logic, you can now really think how to actually store those rules and boards and whatever ships you have there. So how to actually make the stuff savable in the database. So the idea is this, that technically your application should save the data 2 ways, both into the JSON and into the database. So you have 2 save options, just to see that both of those are working. But the database is the kind of the main way how to store data in any business application. And what we have here, the system is not directly out of the box. It's you still need to install some libraries from the NuGet to get the stuff working. But it is kind of nice in that sense that there is only one main library how to do it. It's not definitely the only option, but this is the one option from the Microsoft. And it's called AppDbContext, or basically it's called Entity Framework nowadays. But when you read something about Entity Framework, you can assume that it is about the AppDbContext. And this is a technology which is called ORM, Object Relational Mapper. So this is an approach how to write databases a little bit differently than what you are doing in your database course. We don't write SQL syntax here directly. We don't use any kind of graphical utility to create the database. I don't know what to do there in the database course, maybe PHP myadmin, for example. Or do you write like direct SQL? Create table, blah, blah. No SQLite? Oh, te pole sinna jõudnud veel, jah? Okay. No siis te saate hey jump here. So typically, if you have some kind of Who of you has a database experience? At least, let's say, some web applications, some simple SQLite at least, or MySQL. So probably most of you have something like this. So you know what this is. So if you have written any kind of web applications, you know this, and then you will create your database, and there is some kind of tables, and there's the structure. So you get something like this. So typically this is your workflow. How do you start? You take some kind of graphical design utility and create the database and your table structure here. I can even just you start from somewhere here, create table, name, I don't know, test, number of columns 4, let's go. And you start to select your data types and stuff like that. Or the other way how you do it is that you can do it export. No, what else can I do here? Operations, I think. Collation, copy database, structure only. Go. Okay, I cannot do it just like that. Oh, it tries to copy over it. How can I get the SQL? Export. New template, export quick. Format SQL, go. Will something edit it? No, PB edit. Or we will write something like this. I can remove the crap. So this is what you will do in your database course most likely. So you need to write those sentences manually. So, or at least, let's say you don't need to write them manually. You can create your database using this PHP myadmin or some kind of utility. Then export the SQL, but this is what you have to kind of be able to read, present to the teacher, defend, answer the questions, what is going on here, how are the indexes, stuff, whatever generated. So this is how we work typically, or how do you work typically in the kind of paradigm that database first or design first. So this is not how we do databases actually anymore. So this is good for the learning and definitely sometimes really, really useful. And for debugging, definitely you need to know how to dig around in the structure. But the actual database design in the development is typically done a little bit differently. And I will skip a little bit. And this is how we typically do our databases. We just write the code for it. And we define everything in our programming language. Here it is the C#. And since it's called an ORM, Object Relational Mapper, this is exactly what it does. Maps objects relationally into the database. So the system automatically will dig out from this structure here what the actual database should be. So it tries to figure out that, hey, okay, we have the person. All right, we have the table person. We have the person ID. Okay, the system automatically discovers that if the field name is just ID, or if it's the class name plus ID, then this will be the primary key, the main index into the system. All right, we have the field names, first name, last name. Those are strings, clear, basic columns in the table. What's this? This is some kind of navigation property. So the list of contacts. What to do with that one? System automatically goes and sees, aha, the actual type is contact, goes here, creates a new table, contact. The same thing goes here, contact ID, stuff like that. and here we get the navigation back. So from the person, from the contact back to the person, and then automatically from the person to the contacts. I have to ask, primary key and foreign key, sounds a bell? One-to-many navigation, sounds a bell? Yes, so this is one-to-many navigation, yeah? And how to actually store the one-to-many navigation into the database. So from the one side, you don't have any kind of navigation, and from the many side, you have the pointers back to the one side or pointer back. So this is exactly here. So every contact here has a one person, and we can see here the public int person ID. So this will be the foreign key automatically, since it has the same syntax that the object plus the ID. So this will be automatically constructed as a foreign key, and based from that, when you get the data back from the database, the objects are automatically created in the memory from the raw data from the database, and the relationships are constructed back. So when we load the persons with the contacts, this list will automatically be there in the data, in the object. So if the person, Andres Käver, has 10 contacts, then this list will automatically have 10 contacts in it. And we don't need to do anything manually. Okay, we need to write a little bit code to actually access the database, but you don't need to do anything manual that load me a person, then go and load me the contacts one by one, add them to the list manually somehow. No, this is all taken care of automatically behind the scenes. So this is what the object relational mapper does for you. The entity framework is not, or entity framework core is not the only object relational mapper in the .NET world. There are several actually. This is the one from the Microsoft, and we base our course on that one here and on the next semester. But there are many, let's say, smaller versions of it there, which are working a little bit faster, since they are really lightweight. And there are some like other options of the full-blown system, but most of the world is using Entity Framework Core and will not think about it. What are the other options? So let's go back a little bit. So what we need to do. One notice, there used to be a thing which is called Entity Framework 6, or the old Entity Framework. So this was, or this is still there. It's working only on Windows. And this is the previous version of the Entity Framework. Entity Framework Core now is total rewritten from the scratch, open sourced, etc. So, but if you read the documentation, the stuff you will read or dig about, don't worry. If you read the Entity Framework documentation, this still applies to the Entity Framework Core. Only if you try to do something like really fancy, then there will be differences. But still keep in mind that if you try to seek help from the internet, that you might hit this old Entity Framework. So pay attention, is there this word core or not? And if there isn't, then it's the old Entity Framework, and then maybe you will read something wrong or bad, which isn't valid anymore. Typically should be. Most of the API servers stay the same. Of course, there are some differences, but not really important. We will look into them in next semester. So what do we need? We need few packages, depending where do you want to write your code. So is it if you do the data access layer separately, if you keep your data access in separate class library, then we need to install some packages manually. If we write everything into one single application, into console application directly, since those are already there mostly. So since the library is different, one is the net core app, the other one is the classical class library, net standard. So we need to install the stuff into the net standard. Net core app includes the stuff out of the box. So depending where you are writing your code, you need a little bit different approach. And into the runnable app, so into this command line application we initially doing, so we need to install this one, Microsoft Entity Framework Core design. When you download the stuff from the NuGet, pay attention that you have this word core here. And when we switch over to the web applications, then we will get ASP.NET packages. And then there is also two versions of the packages. Typically is ASP.NET and ASP.NET Core. So we need those core packages. If you install the entity framework packages without the word core, then you will hit this old entity framework, and this will only work on the Windows. So it will cause like weird problems, and typically will not run at all. Sometimes it will run, but you will have like weird problems and weird warnings in the compilation phase. So pay attention that you install the core packages. And one more thing we need is this, to actually execute the scripts, how to initialize the database, how to create the database migration files. We will immediately look into it. You also need to do this from the command line. You need to run this line of code to install .NET Entity Framework tooling into the .NET installation. And if everything is said and done, then you first need to create those models. So those are called typically POCOs, plain old C objects. So this is how we define our database kind of structure. So this doesn't actually define anything for the database, but the database can pick up the structure from here. And this is how you actually set up the database. So we have this, you need to create a class which is derived from the DbContext. So this will set up your database. Then those will be your database tables. So those need to be from the DB set with the generics of the class. So those, now the system can know that, can go and pick up the class names from here or the class structure from here.
Question, are these fixed or you can later change them dynamically?
Dynamically, no, but in the code as much as you want to. So no, you cannot do them dynamically because the database structure also needs to update. You cannot just add tables dynamically. Theoretically, yes, you can actually, but this is like advanced programming because then you need to create the database structure also dynamically. So if you try to generate classes on the go, theoretically possible, but don't go there. Theoretically, yes, you can. And finally, there is one important method here in the DbContext we need to overwrite. This is called the OnConfiguring. So here we actually need to tell to the entity framework, because entity framework doesn't know anything about the exact database engine you're using. So entity framework can use several different database engines. So now we need to tell to the entity framework that, hey, what is the actual database engine you are planning to use? So out of the box, if you don't do anything fancy, then probably this use SQLite, because this is file system based. And this will work absolutely everywhere. So you don't need to worry that, hey, do I actually have access to the Microsoft SQL Server instance, or do I have access to the MySQL database or stuff like that? So the SQLite will always work for you. The only thing is that you need to specify the full path as a parameter here. So where to actually store the database for the SQLite. If you are on the Windows, then you can use this. So the Windows installation, especially if you did install the Visual Studio, then you will have this local DB, which is a single user Microsoft SQL Server. And if you didn't install the Microsoft Visual Studio, then you can just go and download the local DB installer and install it from the Microsoft. But this will work only on the Windows. This will not work in the Linux or in the Mac or wherever else. So this is purely Windows only.
One more question. If I have a class within a class, how does that work? Or it needs to be separate?
Will work. Don't go there. So not a good idea. Will work actually. So all kinds of inheritance, and there's like fancy tricks we can do in the entity framework. But no, keep your stuff simple and don't do internal classes. So this is not nice. So basically, we have one more slideshow about it in more details, but let's try to get some hands on the code first. So the approach is that you write your models So step-by-step kind of like overview what we need to do. You write your models. Typically we do them in the separate class library called domain. So the low-level description what our application is about. Just a reminder that in the entity framework, everything you try to say to the database needs a primary key. Not always true actually, but for you it is true. So always have this ID or the class name ID on your table or on your POCO. So doesn't matter which approach you take. Entity framework supports both. Initially, it's a little bit easier to work with this in this shape that you have this class name ID. Later on, it's easier to switch over to this purely just use this ID as a field name. So then finally create this DB context, add all your stuff there. So add those DB sets. One important notice is this, that don't forget to add them all. You technically don't need to add them because Entity Framework will discover all those one-to-many relationships or one-to-one or whatever relationships you have there. It will discover them automatically. And if you only, if I go back here, if you only point here to the people and forget those contacts or contact types from here, then actually when you go and see what is there in the database, you will see that you have still all those three tables because from here, from the person, the Entity Framework will discover that, hey, the person actually needs the contacts, goes to the contacts. From the contacts, it will discover, hey, there is also contact type, and also goes and finds the contact type and automatically creates all those necessary tables because otherwise we cannot work with the persons. But you will not have the access to them, so it's hard to access them directly. So don't forget to list all your DB sets. If you forget, of course, nothing bad happens. You can just add them later, but initially it is confusing. And kind of biggest recommendation for your entity framework career is that please always check your database structure that it is matching what you have in code. So as soon as entity framework is doing something automatically, if you see some weird primary keys or weird foreign keys or weird table names which you didn't create, then you have to be absolutely totally sure that this is what you want. And typically this isn't what you want. And when you define your project to us, then we definitely will check that what the hell is going on there in the database, and then you have to explain to us why do you think that some kind of shadow properties or auto-discover table names and stuff like that, why is this okay, and why you think it should work like that, and what for is it good. So always check your database that it actually matches what you have in your code. Then some more technical stuff. It used to be, or if you read the documentation from the old entity framework, that the database was automatically created for you. So as soon as you started to run your code and started to access the database, then automatically database magically appeared. This is not so anymore. So it was quite a few megabytes of code which was included with every entity framework installation or with application. So finally, community decided with the new entity framework core that this is pointless. We actually can remove this few megabytes of DLL from your app and use this functionality locally, and let's just create the necessary kind of SQL statements and execute only the SQL statements and not generate or not include the whole code base, how to analyze your C# code and find what the class structure is. So now we need to do this manually, this step. So before you can actually run your code, you need to create those database creation files. So this is done with this command here. So this is from the command line, .NET EF migrations add, and then the migration name. So this will create a new migration for you. So basically this migration will check what is there in the database, what version is your database currently installed, if any, and then finds the necessary files, or it creates the necessary files, how to create the database or how to upgrade database from one structure to the next structure. So we can actually add more migrations when you create or when you modify your database, or when you modify your database structure, let's say, when you add some new fields to the tables, then you don't need to like destroy everything and start from the scratch. We will just add a new migration on top of the already existing one, and then system will automatically generate like necessary update statements. It will not drop tables and recreate everything from the scratch, but will just modify the data structures. And then you can also work with the data. So how to actually migrate data from one structure to the next. That one, of course, you have to do manually if need be. And then when the databases or those files are created, we can tell to the dotnet that, hey, now you have the structure defined. Now please also execute those files. So create the structure. And then the database is updated. And then your app is ready to run. This step also can be performed from the code. So you don't need to do it manually, although you can, just to check the stuff out, but can be executed from the code also. So the migration step can be done from the code itself. So when you give that to the client will go install it into the server and just run it, and hop, database is updated. I think typically, if I think back to my own projects, last time I checked my some kind of sporting event registration system, I think my migration count was somewhere in the 700 something updates. So over a few years. So it just keeps coming and coming and coming and coming, and new field, new table, new field, okay, few new tables and stuff like that. So it just piles up and up and up and up. So those are keeping coming. So the system, when you do this database update, then the entity framework will go find what is there in the database, what version of system is currently running, and then starts to apply the missing migrations one by one. So in my case, if finally I killed them all and created from the scratch the new initial migration, but when I tried to kind of initialize my database from the scratch in the new installation, then the system ran all those 750 migrations one after one after one after one. So started with created just the database with one table, and then started to add stuff, and it finished with like, I don't know, I have now currently I think some like 70 something tables there. So it was quite a slow process. So, but the system takes care of that one automatically. And finally, when you have your update, when your database is created, go and check that what you have in the database. Check that the structure that the database has generated for you is exactly what you expect, so that it will match one by one with your code. So here we can see this contacts, contact ID, yes, it's a primary key, integer, cannot be null, contact type ID, yes. So this is for eigen key, so this points to the contact type ID, primary key, okay, those have to match the for eigen key and primary key, not null, yes, contact value, yes, this can be unlimited string, not the best option, but yep, that's what my code said. And the person ID, yes, also for eigen key, goes to the people here. Okay, seems to be that everything is as I want to have. And of course, out of the box, the entity framework will use all the fancy SQL features or do them manually. So you have something which is called for eigen key integrity. So if you create a contact, if you try to insert data here, then the person ID and the contact type ID you are trying to save to the database, come back. Those have to be existing values in the contact types and in the people table. So you cannot insert wrong data into the database. And the other way back, if you try to delete, for example, if you try to delete the people, or let's say you try to delete the contact type, let's say you kill the Skype, then automatically there is a system which is called cascade delete. So if you remove the contact type with, let's say, the ID 1, then system knows that this is not possible because the contacts point to this contact type. And with cascade delete, automatically all the contacts with this ID is deleted, where the contact type is 1. So if you delete the Skype, then all the Skype records from the contacts table is also deleted. So the cascade delete. So we can turn it on and off. We can work with it. But out of the box, we have this cascade delete functionality and referential key integrity. So only valid data can be in the database. And then finally, when everything is said and done, your database is there, everything is working, the structure is matching, everything is okay. Then finally, we need to work with the database. So just create a new database context. This will automatically open up the database, log into it. If there is a username and password, then it's some kind of remote database. Give you the access to this DB instance. And from the DB instance, we have those people and contact types and whatever we have there. And we can just kind of think about them as some kind of data collections. So there are methods like add and remove and find and whatever else. So you can just kind of work with the data. So this is how we add the record to the database. And this is how you list all the data. Just iterate over the table, so over the collection. And just write everything out. One notice here. This entity framework implements something which is called unit of work pattern. So everything is done initially in memory. So if you do this DB people add, nothing will happen in the database actually. Everything is just in memory. So you can do several adds one by one and not save anything to the database. And the data will be synced to the database only when you call this db.savechanges. So when you call this, then the actual SQL sentences are generated and the data is inserted into the database or whatever, deleted or whatever you did. So this is called, we will look into that heavily in the next semester, but this is called unit of work pattern. So basically, we create bunch of work and then we do it as a one single unit. When you have defined what the work is, so delete something, remove something, add something, and then you say save changes, then it's done as an atomic save, it's called. So if something fails in the middle, then everything is rolled back. So you either do everything or you don't do anything. So it's kind of unit of work and kind of like obvious that if something fails in the middle of saving data into the database, then you will probably have some kind of not normal state in your database. Like you have the invoice, but you don't have the lines on the invoice, so you have corrupted data in the database. So it's bad. So here it's automatically implemented that if something fails with some of your operations, then everything is rolled back and you haven't done anything.
How in that case the IDs are generated and used? I add a person, I want to add a contact, how do I match them?
We will speak about it, or we'll test it. So it works two ways. Entity Framework supports graphs. So if you add, let's go back here. Where's the structure visible? Let's go here. So if you create a contact and don't touch the person ID, leave it as a 0, and at the same time don't touch the contact type ID, leave it as a 0, so the default value. But attach here the new person and the new contact type here. And now when you insert the contact into the database, the Entity Framework will see that, okay, this is 0, but this isn't actually null. The person is there. And then it creates a new person also. And it's smart enough to do it in the correct order. So it first goes, creates the person, then goes and creates the contact type, and only then inserts the contact. So there's a fancy phrase, fancy logic behind the scenes, how everything is kept in sync. And when you have done this save changes, we will see it, how it works. But here we create this new person kind of dynamically as an anonymous object in place. We don't have the reference to it. Oh, come back. We don't have the reference to it. But if you would have reference to it, if you create it outside here, some kind of, let's say, x equals new person, then when you have done with the save changes, the person actually has the ID inside it, the person ID, the value will be updated. And you can see what the ID is of the object. You don't have to do some magic tricks and go back to the database and ask that, hey, give me the IDs for those just inserted records. So Entity Framework is actually tracking, it's called tracking. It's tracking those objects in memory. And when the actual database operation is done, records are inserted one by one, and when everything went okay, Entity Framework will collect those IDs and update the records in memory. So you can see that, hey, the IDs are now there. So this is the basics. Yep, nothing wrong here. And let's try to use it in the practice. And then when we have some practice about it, we can go a little bit into the theory, how the stuff actually works and what are like useful options. So fire up your writer engines and let's write some code. New solution. DbDemo. Console app. So where is our C#? 2020 course materials, demos. Okay. So I created a new empty solution, which just console empty new console app. So hello AF core demo. Yep, it is working. So from the slides, you need to do this. .NET tool install global .NET df. .NET tool install global .NET df. I can't because I already have it installed. But instead of install, I can try to do the upgrade. No, update. Yeah, and even got the update. Fancy. So now I have a newer version. So 3.1.9 seems to be the current latest. So now let's write something. So new project. This is the class library. I try to be nice and it's net standard version 2.1. And let's call it the domain typically. So this is what is our app about. So the lowest level data structures that describe what our application is doing. Let's try to figure out what our app is doing. Everybody's favorite thing. Yes?
Can you show the install command?
I want to copy it. Panen Teamsi kuulge. So let's figure out what to do. For example, everybody hates the study information system, the ÖIS. God awful. can you do a better one? So let's try to, for example, give grades in one subject to the class full of students. So what do I need? Give me the data structures.
School.
Don't go so complicated. It's just a student. Okay, we have the student. All right. Let's do this. We have one subject only, this C# class. I want to grade everybody here. So we have the student. What else do I need? Homeworks. All right. Yes. We have the homework. What else?
Grade.
Grade. So let's write it a little bit better. Let's put the grade in the middle. Grade and homework. So I don't write the field names here. Of course, there's primary key and name and whatever else on the student. So what will now happen? We have the connection from the student to the grade. Can the student have many grades? Yes. Can it have 0 grades? Yep. So it's this. Can grade have many students? Probably no. Grade always belongs to somebody. This is your personal grade.
What if it's teamwork?
Don't go there. You still get the personal grade, even if it's teamwork. So there's one here. From the homework to the grade. Can one homework have several grades? Yes. I mean, everybody's grade in this homework. So homework leg 1, everybody should get a grade, or hopefully. So there's many. Can the homework have no grades? Definitely. So 1 also. Can one grade have many homeworks? No. So we have this kind of classical database structure. All right. Let's try to write the entities for it. So we have the student. So always start with the primary key. So, and if you keep it to this name shape, either it's just ID or the class name plus ID, then it's automatically discovered as a primary key. If you do something like this, then Entity Framework cannot help you. Then you have to do manual configuration. But don't do it. So keep to the kind of standards. What else student has? Yep. So those are strings. Maybe it has like first name and a string. And now we can think about it, something fancy stuff if we want to, like date of birth and average grade and whatever else. So, but technically we don't need anything else initially, so let's keep it as simple as possible. And of course I need to here rename file to match type name, so it's a student CS. Okay, add class interface. The next one is homework, let's say. Homework ID. So what does homework has? Description probably, yeah? Yep, deadline most likely, but date times are kind of like finicky subject always, because date time are dependent of what language you are working in and what your system is doing. So it's kind of complicated topic to cover. So let's skip the date times for a while. Although they will most likely work out of the box, but still kind of date time can be a problem. What else does the homework has? We can also say that it's kind of like, is it pass or fail, or is it graded or whatever, but let's keep it simple that it is just automatically just only description. So we don't need anything else here. And now finally the grade. So now we can think about it, and from the viewpoint, what you will learn in the database course is this, that you don't need this grade ID here. Because grade is always uniquely identified by what? Student ID and homework ID. So theoretically you can create the primary key in the grade out of two fields. Composite primary key, it's called. And from the viewpoint of database course, it's correct, and probably this is what you need to do there. From the viewpoint of practical programming, don't do it. Because it's really, really complicated, especially in the context of web applications, to work with composite primary keys. Because you need two separate values and you need to glue them together somehow, especially if you go to the actual website. So if you do some kind of drop downs, and you need to select the value from the drop-down. And then it's really complicated if this primary key is not a single field, but some kind of mix of whatever. Then it's hard to work with them. So actual real-world approach is that although this is kind of redundant and I shouldn't use it, actually I will still create it and use it, because it's just much more convenient and much, much faster. So let it be there. And now we have what? Integer grade itself. Let's say grade value. And this is it, what grade will have. So our basic definition is done. We have the students, we have the homeworks, and we have the grade between them.
What about foreign keys?
Now we need to do the navigation. So the basic properties are there. Now let's start to add the navigation properties. Those are called. How can we navigate from the student to the grade? So typically in the AppDbContext, we use something which is called ICollection, the interface. Not the list or the iList, but the ICollection. And the reason is that the lists in .NET have several different interfaces, added one after the other one. So IEnumerable, ICollection, there are like plenty of those. The difference is what kind of features the interface specifies. And the problem, or why we don't use, technically we can write just a list here, kind of classical. But the list, for example, has indexed access. Can you do indexed access into the database? Probably not. Because when you do some kind of where sentence, select something from database, from table, where, and then you limit your options, then what will this indexed access even do? Where will it go? Plus you don't have the connection between the kind of what is in the database and what is in the memory. So it's kind of like the list is not the correct way. Plus list will have the operations that you can delete the element from the list by the index. So you can remove the element from the middle. This is definitely not something you can just like that do with database. Or you can, with the list, full list, you can add an element in the middle of the list. So you can move everything away. So this is also kind of like weird concept with the database. So here, the most closest what the database actually has is this ICollection. And it has a bunch of grades. Okay. Now the technical kind of programming approach is this, that when you create a navigation property from one side, you will always go and describe the navigation property from the other side. So those properties which point to the other classes, either with the collection or directly, those are called navigation properties. So when you define the navigation property from one side, then go and describe it from the other side also. So here it's just the student. Now, the foreign key here is not mandatory. You don't need to define the foreign key. You can skip it. Then the system, the entity framework, will create the foreign key for you automatically. But then you cannot access it. And then it's really inconvenient to how to program the system. Then you always have to work with this student object. So it's better to add the foreign key. And the syntax is the same as with the primary key, field name or property name plus ID. So this will be the FK foreign key. And this is now, we are using system which is called convention over the configuration. So it's kind of programming paradigm. So we have the like sensible values configured for us out of the box. So the system tries to find out kind of default approach and use it automatically. We don't have to do anything specific for it. But there are ways. If you want to do something like this, social code, for example, if you want to do something like this, and maybe do it like a string, so you want to store the social security code, isikukood in Estonian, then now the system cannot help you. It cannot discover that, hey, this field is actually a pointer here, so it's actual foreign key for that one. So now you need to do some manual configuration, how to explain to the entity framework that, hey, please create the foreign key out of this. We will look into it somewhere, but not now. So we keep it as a standard, so system can automatically discover everything. So it is a student ID. And it's an int, yeah, not a string. So the type, what you're using here, this type here, it has to match with this one here. So string primary keys are totally doable, but once again, you cannot have auto increment with string primary keys, then you have to set the values manually. So we can write a comment here. Type has to match with TK in another entity. Okay, and now we have the other direction from the grade, from the homework. We have the ICollection of every homework as the grades. And I forgot here, it's called grades, not type. And from the grade, we have the same way navigation back. So it's the homework, and we need the foreign key. So now the system is, or the database tables, or the plain old C objects, let's say more correctly, are there that will describe our database. So now we can add another project, which is typically called DAL, which is acronym for Data Access Layer. So all the database operations or the database kind of utility classes are typically stored in this project. I'm trying to push you into the kind of correct project structure or solution structure. we could write everything in one single program.cs, like bunch everything together. But this is what we typically tend to do in the beginning. But this is really, really bad code organization and will hurt you later on. So I'm trying to do it correctly out of the box with you, more or less. We ended up last semester with what? About 20 projects or something? Plenty. Quite
15 at least.
15 at least, yeah. Quite a few will be there finally. Okay, this will be our application DbContext, which has to be derived from the DbContext, which we don't have. So we need to install something. And there's this fancy option here, if you take the context sensitive menu, which is this, find this type on NuGet.org. So this will open up the NuGet manager and put this string here, t colon, so type colon, DbContext, and tries to find what is there. And now this, don't first check that your pre-release is not checked. Don't use pre-release packages unless you know what you're doing. And then this, we have this entity framework and Microsoft.EntityFrameworkCore. So one is Windows only, this 6.44, don't go there. We need this one, Microsoft.EntityFrameworkCore, not the Entity Framework. So don't mix them. And now I have this import missing references in file. And now we start with those DB sets, so the actual database tables. So we have the student, and I need the reference. Please give me. Domain and use student. So this is students. And don't forget the rest of those. We have the homework. And finally, grade. So far, everything is abstract. We don't have any idea what the actual database will be. So what kind of database backend we are using, we have no clue about it yet. So we need to use something. So we can try to start with this SQLite. This works locally. You don't need any kind of username or password, and it works in all the platforms. So let's go back to slides. So we need to do this method, OnConfiguring. And set up the correct way how to use the database. Options builder, dot, and we only have what? Nothing. The only one that will work for us out of the box is this. Is probably memory cache, or even that one is something not really useful, I think. So we need to install some kind of database providers for us. So we have those Microsoft.EntityFrameworkCore.SQLite and maybe SQLServer if you have access to the SQL Server. So let's manage packages. SQLite. Very well. Didn't help me. Microsoft Entity Framework Core SQLite design. InitialCreate.SQLite. No, I got it. This one. And I can also try to install immediately the SQLServer. Just in case, maybe I will find out some SQLServer from somewhere. And now when I write use, now I have those, use SQLite and use SQLServer. So let's start with this use SQLite. So this only takes one value, which is the connection string, which is in this shape. So the data source equals, and should be some kind of path. I can try to create it locally. So let it go where it wants to go. So now this will create it in the whatever is the current directory when that app is running. So basically my database is there, should be there. So now I can try to use it. Let's say what we have, db.students. Let's just iterate over them, and let's just write something out. And to write out a student like this, I should probably go and do some nice toString here. Student ID plus first name plus space plus last name. I don't know, maybe like this. So now this construct here using, so why it's written like this and what does it actually mean? I think we didn't have anything about it on the slides. So anywhere. So what's the idea here is this, that when we do this new AppDbContext, then the database connection is opened up. And typically when you open up the database connection, you also need to close it somewhere. So don't leave the database hanging into the memory somewhere. This will cause some kind of problems. And for that one, we actually have something which is called db.dispose. So this will close the database connection and destroy whatever needs to be destroyed in the memory. So everything is released correctly. But to do it automatically, we are having this. We have this language construct which is called using. So we declare the variable. And using is only used for something which is called IDisposable pattern. So the AppDbContext is IDisposable pattern implementation. So it has this dispose method. So automatically when you do the using with declaring some kind of variable which has the dispose method on it, so when the using is ended, then the dispose is called automatically. So when you hit this line here, then the DB will be closed and gone. And now, since you're declared the variable here inside the using scope, then also the variable is locally scoped, so we can't do the DB here because it's not even in the scope anymore. So the garbage collection can come and destroy absolutely everything. Now we have this green line here, and when you click on it, we have this convert to using declaration. So this is now the fancy syntax in the C#8. And we can do now this. Now we have the new syntax for it. Now we don't have this curly braces here anymore. So now this DB will be automatically destroyed when this method ends. So here automatically we save this db.dispose. We don't need to call this anymore here. If you remove this using, then you have to do it manually. So this is the new way how to write it. So we just use this using, and then automatically db.dispose is done for you. And the old way is this using in the parentheses like this, and then have a block of code where it is stored inside. So that's up to you which way do you want to write it. Kind of this is the new fancy way is to do it like this.
Looks cleaner.
Looks cleaner, yeah. But you have to keep in mind that automatically the DB gets like destroyed here and at the last line. But yeah, it looks cleaner. And I try to run the code and it crashes. No such table students. But at least it got somewhere. So the result is that we are missing the database. So the actual everything kind of started to work. The SQLite was opened up. Everything is installed correctly, and then it tried to access the table, and it couldn't because we haven't created it. And it will not create it automatically. So now we need to help the system out a little bit. So we need to do this migration to actually get it into to create the necessary files for it, how to create the database. So where's my command line? Terminal. So now the commands a little bit depend where do you run them from. So I'm currently inside the solution folder. So it's .NET EF migrations add InitialCreate. And when I run it just like that, no project was found. So it doesn't know where is actually the database context stored. So project dull. Let's run it again. And now it's unhappy that, hey, okay, the dull is there, but this is not the runnable thing. So it needs to also know what is the startup project, where the code execution starts. But it gives us the help that we need to specify this startup project, and for us this is the console app. And now the next problem, your startup project doesn't reference this package, so we need that one. Let's add it. Let's try it again.
What was needed to add?
It will show you this error here. Doesn't reference Microsoft.EntityFrameworkCore.design. So add it. And now everything went fine. just run, and now we can see what was created where. Should be here in the DAL. Yep, we now have this folder, migrations.
Is the syntax different on Windows where you get some errors that couldn't execute because the specified command of file was not found?
Did you install the tooling first?
Yes.
Try to just, if you run the just command .net, what will happen?
Shows me. I get build failed.
If you get build failed, then go here and try to do build rebuild solution, and then you should see where the error is. Kerro minä vaata, miks seal build failib.
Can you show the AppDbContext?
But those of you who have the problems, I would say that buying the Mac helps a lot. This is like my standard recommendation for all the problems. Buy Mac, it's much easier.
Rasmus said exactly the opposite. You should buy a PC because all the ER3 tools are.
Here the fancy tools, yes. Those are on the PC. But for that we have, oh, sorry. But for that we have this. So what's the problem with the Mac? There's a Windows if you need to. So I can jump from Mac to Windows if I want to. Sometimes I need Windows. And now when you have this done, you can inspect what was created here. So there's 3 files here. You can go and read the code. You can see that there is created a C# class with the statements how to actually create the table. So it seems that all our database or the table structure is described here. So all kinds of SQLite, auto increment, blah blah, students, first name, last name, primary keys, foreign keys. Yeah, it seems that foreign key and integrity is here. On delete, referential action, cascade, so also with the cascade delete. Then some kind of designer file, who knows what this one is. And then some kind of model snapshot. So basically, you do not modify almost anything here, so don't touch them. You can just read them. The only place, if you need to do something, is this InitialCreate, not the designer. So this migration file itself, the base migration. And we can see here, we have the up method. We have the down method. Drop table is here, so it goes back where it tries to be. And sometimes when your database migration needs to do some fancy stuff, for example, you decided that we can try to do it later. No. Go to hell. Taha seda, siia saata. No siia. For example, if you try to get rid of the first name and last name, and you try to glue them together into one field, let's say name, then you need to take different steps how to actually achieve it. First, you need to create a new field into the database. Then you need to copy the data from the old fields to the new field, and only then can you drop the old fields. Otherwise, we will lose data. So then those things you need to fix here manually, and then write some specific SQL statements here how to actually migrate the data from one field to the next. But typically, if you just add stuff or you extend something, then you don't need to do anything. So the data will always fit there, and everything is like kind of fancy. As soon as you start to drop data, let's say you start to limit the string length, then you always have to take care what will happen with the like extra data where will.
And then you have to change it in there.
Then you have to change it here, or otherwise you will just get rid of the data unexpectedly, and you will lose your database content.
Can you show AppDbContext?
That one? So now when everything is said and done and everybody has successfully created the migration, you can run this .NET EF database update. Where's my terminal? No, .NET EF database. And I need the same startup parameters, those project and startup project. Go ahead. Microsoft.EntityFrameworkCore.SQLite. And now when I actually run this .NET EF database update, then this once again compiled the project, and then it tried to apply the migration, and it went successfully.
You're getting 0 points.
sul on mingi vale Mac, mul on küll.
mul on sama see.
kas sa pead paremasse Maci poodi minema?
Paremasse pole.
And now when I run the code again, now what? No such table, students. Oh, okay, now I know what the issue is. Now the issue is this, that when I create the migration and apply the migration, this is executed from different directory than the actual runtime. So that's why I had on the slide also that fix the path. So let's say for me it should be something like, I don't know, can I do it, for example, like this on the Mac? Can I fix it into the home directory? This means that I need to run the migration again. So let's try to update it again. No, now I have this unable to open the database file. No, this is not correct place for me.
That's what we do.
So this is what it is on the Mac users. Is it like this? Yeah, users, Akaware, and then maybe development, and temporary directory. Let's try again. Yes, and let's try to run now it. Yes, it's working. So the relative path is a suspect. That's why I also have on the slides that specify full path to DB location. Otherwise, the migration will create a database in one location, and the actual runtime will try to access it from different location.
So at first you put it wherever, and then
I put it in the current directory, but the current directory is different for the migration when the migration is running and when the actual application is running. So to get it to access it from the same directory, to create it in the fixed directory and then to access it from the fixed directory, you need to specify full path. So for me it's this users, then my username, then my development catalog, then the exclamation point where I give my temporary stuff, and then create it there. And now I can also go and check what did I actually achieve, what is there in the database, or what is the database structure, because my code is now running, just my database is empty, so I cannot show anything here. I need first to insert something in the database. But I can go and see where can I navigate, view, Explorer, structure, Azure, where is my server Explorer? Tool windows. Database. So we have here in the rider this database utility or database view utility. We need a new connection, data source, and there should be SQLite here. Yes, there is a SQLite. So we need this file, so since SQLite is file-based. So this is in the development, exclamation point, this AppDb. No, cancel. I don't want to create a new one, I want to point to existing one, this one. Test connection. Yes, went okay. Schemas, grades, grade ID, integer, auto increment, yes, grade value, student ID, homework ID. Yep, seems to be okay.
Can you push it?
I can push myself. Yes, I can. Oh, no, let me see. Do I have some kind of git ignore also here? Otherwise, I will once again store God knows what. No git ignore here. Now I can push it. Jep. nii, kas nüüd on kõik tööle saanud või?
Mis sa panid sinna sellesse local SQLite, et sa, ma mõtlen see config, mis sul on seal?
Mis sa mõtled täpselt?
See database view.
See siin või?
Jah, mis sa panid sinna config'is?
Teeme kohe uuesti, oota. Sellest lahti siin saan. Disconnect. How can I remove it?
Remove center
ei, ma saan teha siit, on ju.
in the middle.
Data source, SQLite. Siit ma lihtsalt lähen otsin selle faili ülesse. AppDb ja sul on vaja path'i ainult sellele failile.
See on probleem, et ta migra käigus ütleb InitialCreate is used by existing migration.
See on kindlasti probleem. Siis sa oled teist korda sama migratsiooni juba loonud.
Ma panen sinna siis 2.
Absoluutselt, jah. Või siis sa võid, mida alati teha saab, on ju, if you want to start from scratch, then just kill this migrations folder. Just delete it. If you don't want to do actual migrations, I mean additional migrations, then just kill the migrations folder and then create a new initial migration. Otherwise, you need to specify a different name. The initial migration is just, or initial create is just the first one. So don't try to do something there. So don't try to define the same migration twice or create the same migration twice. Seda path'i, jah? Sul on Windowsis mingi teine path muidugi? Sul on mingi C:\, midagi. Ma arvan küll, jah. No Windows, jah. This is path to my home folder and then some temporary directory.
Windowsis peab backslashi'd ära ka escape ima.
Äkki peaks selle äpi ette panema?
Ei, 2 korda paned seda backslashi'd.
2 korda paned backspace, jah?
Mida pidi välja ka näitama?
Kaigas. No, we don't have any data in the database. It's empty. Now we can try to actually save some data to the database first to actually see that it is working. So here in the Program.cs. And now you can see I have this AppDb in several places. So this is what the initial migration did for me. So this is definitely wrong. Let's just delete it from here. So now I can do this db dot, let's say, students. Let's try to do this. What we speak about that the entity framework works with the graphs. So we can do this. Let's say var. What we have, grade is in the middle, yeah. So we have the new grade. Sorry, there is no constructor. So we have the grade value. Of course, I will get the 5. Then we have the student here. Let's create a new student in the place. So the student has the first name. This is, of course, me. I'm the good student. Weird. And then, of course, we have the homework, which is a new homework. Which has the description. Set up creating in Moodle finally. So the grade value should probably like maybe 1 for me. At least I'm thinking about it. So this will create the new grade with the objects inside it. So now we can try to do this to save everything into the database. So db.grades.add grade, and finally db.grade Save changes. This will actually save data to DB. Now we can try to see what will actually happen when we save the data. And let's say, let's modify this one. Let's take the grades. And this is the grade. What the? So let's write the grade out. Oh, the name is bad. We already have the grade here. Let's say it's a DB grade. And let's see what our grade will look like. And let's write the same thing out here. Oota, kohe, ma lõpetan selle sõna ära. Nii. After add. After save changes. This is from DB. So let's see how the grade will actually look like just when it is in memory, when it's added to the entity framework, but not yet saved to the database, when it's saved to the database, and then actually when we try to load the data back from the database, what we get then. So what is going on there? And here in the grade, we just need to do the like this and toString to actually write it out correctly. So let's try to do some kind of fancy string interpolation here. So first we have this grade ID. This we have. Okay, there's no problem with that one. Then we have the grade value. Okay, then we have the student, and we can try to print out the student here. And then we have the homework, which will try to print out the homework. But since we want to see the IDs also, so let's write here the foreign keys. And maybe move that to somewhere here at the end. Okay, hopefully everything works. Student already has the toString, and let's do the same thing in the homework. So let's try to run it. Will it actually run? Yes. So before add 0, 1, okay, the 1 was the grade value. So ID is 0, student ID is 0, homework ID is 0, and everything here is also 0. After I add, all the IDs are still 0, but after save changes, the IDs have been updated to the 1. So now I have the data in the database. And if I run it again, yes, the adding is the same. Save changes now has the ID 2 and getting the whole data from the database. Now I have some weird results here. So the first line has the student ID, has the homework ID, but the student and homework itself are null. But the second line has the data for the student and for the homework. So this takes some explanation. Why is this happening? And what the entity framework is doing is called tracking the objects in memory. So when you create the objects, when you create the object, here we created this second row with the IDs 2. Entity framework now has it in memory. And even if it did the save changes and updated the IDs into the objects, it's still tracked in the memory. So now when we do the request to the database that give us all the records from the database and we start to write them out, when it hits this second row, it automatically knows that, hey, I already have this data in memory. And all those foreign primary key relations are updated correctly, and we can print out the objects like this. But for the first row with the IDs 1, it doesn't have them in memory. So here we need to do something with the database to tell the entity framework that, hey, actually go and get the data, the full data from the database. I don't just want to get the grade. I also want to get the grade with the student and the grade with the homework. So I need to do something to actually deload the full data set from the disk or from the wherever the entity framework is thinking it is. So we need to do something with that one. So I can now push it to the Git again. Nii, nüüd on kõik Gitis, võite Gitist kõike taga ajada. Või mõningasid scrollida, kui tahate. Või midagi vaja näha. And now we can do the next fancy thing, which is this, which we kind of skipped initially. We don't have the nullable references, which is actually mandatory for you in all the projects. So let's add that one also here. So we have this directory build props for it. And now I have plenty of mistakes here, which I need to fix. So let's start from the grade. What does it complain to me? Student. Non-nullable property student is uninitialized. This seems to be the correct way, because the actual value for the student should come from the database. So I cannot set the value to the something. So I can just tell to the compiler that, hey, be silent. The same with homework. So null. null with this exclamation point, the null forgiving operator. Because all this data will come from the database, so when the data is loaded, then hopefully it is there. Now I need a little bit think about it. Is it really so? Creates? No. This is actually not correct. This is question mark. This can be null. If you don't include it, if you don't tell to the entity framework that please load it, then it will not be there. The first name and last name will be there. So the navigation properties are actually nullables. So those will be with the question mark. But the strings, those will be okay. And the grade. So the student, this one here, yeah, this can still be null if you don't include it correctly. So those will be with the question mark. Okay, now this AppDbContext. Yes, those will be set by the entity framework, so we don't need to do anything fancy here.
How to enable this null thing?
I just copied my directory build props from one solution to the next. You can take it from the Git, from the demo 1. It's there. I copied both the git ignore and directory build props from the demo 1. And now you can do this fancy add new solution folder, solution items, add existing item, directory build props. Now you can see the file itself. And then you can do even fancier tricks, edit solution file, because git ignore is not visible, and then you can just manually add the git ignore here. Yes. And it went to the Git. Okay. So currently we only have one issue here, that what to do with this, that when we run our code, we always insert a new record. That's okay. But when we get the data back from the database, it's first two records, so anything but the last doesn't have the student and homework included into the dataset. So we only ask because here we only access the db.create, and this will just list the grades and will not get additional data. So if you know your SQL, then the no join is done, so no data is included. Yeah. So something needs to be done to actually tell to the system that, hey, please take whatever is the additional data we need with it. Please take this one also with it. So make a one single request. So how much time do we have? 1 hour and 30 minutes. All right. So let's take some 15-minute breaks. 15-minute break, and let's go and eat. I definitely want to eat. And then let's continue. Not sooner than 2:15. So 15 minutes minimum. All right. So now you have the basic grasp how the Entity Framework Core is working, how to create the model, how to set up the DB context, how to create the migrations, how to actually execute the migrations from the command line, then how to access the database, how to get the data out, how to get the data in. So there's actually quite in-depth topics to cover here. So here in this semester we will touch the really basics of it, and in next semester we will dig into it heavily for quite a few lectures. So some more basic stuff. You need to get your stuff working. So first, how to actually see what is going on. So what is the SQL generated behind the scenes? So there have been several different ways how to do it. So if you try to Google it yourself, you can see many different solutions. So this is the current, the latest with the current .NET Core, how we should do it. The main focus of the .NET Core is not definitely on the console apps, but on the kind of bigger applications. So there we have some kind of dependency injection and how the whole this system works, but we can pull out some of the pieces from there and use it manually. So this is the way how to set up the LoggerFactory, how to create the logger in the .NET Core. And this logger, when we create it, there is a bunch of magic methods here behind this LoggerFactory create, what is actually done. But for us important is this add filter. So we add filters to the loggers that when system tries to log something, then what messages at what level we want to see. So we can specify here by the strings what we want to see. And when we have defined the logger, we can actually see what is going on. When we create this database connection, we can add here this use LoggerFactory, this method that, hey, dear options builder, please tell to the entity framework that plug in this logging system. So then the whole system will use this logger. So let's try to do it. Then we can see what is actually going on. And we also need to install one more package, this Microsoft Extensions Logging Console into the DAL. Logging, Microsoft Extensions Logging, and this logging console. So let's add this logging console, and I think it will take everything together what is needed. So now we can actually write this LoggerFactory. So it's a private static read-only. This is ILoggerFactory. LoggerFactory create. And this has some kind of boiler. And now we can just add filter into it. And finally to the add console. So it will log out to the console. So you can try just to log out the Microsoft something. use LoggerFactory, and now we can specify our LoggerFactory into the system. So this will hopefully add the console logging. And now when we execute the stuff, we can look what will happen, if anything. Yes, we have plenty of output on the console. So let's see what is actually more interesting. Okay, we can also turn on something which is called enable sensitive data logging. Let's see, is this something usable? But for us, maybe more interesting is those Microsoft.EntityFrameworkCore database command. We can log at those, or we can also see that the debug is not kindly interesting, but maybe the info is more interesting, so we can just try to turn it to the level of info. So not the debug, but information. Otherwise we just have too much stuff visible. Yeah, now it's much more better. And now you can see how the stuff is actually generated. So what are those SQL statements that the system is doing for you? So this is when we try to actually save the data, what will happen. So insert into the homeworks. So the homework is created first. Then the student is created, first name, last name. And then finally when it has it, then it goes to the grades and tries to insert the grade with the correct foreign key values. And always takes back this last insert row ID, so it gets the value for the whatever was inserted. And then finally this select from thing. And this you can see from the select statement that it only asks for the content of the grades table and nothing else. So we don't get any students and homeworks back from here. So this gives you the insight what is going on. So if you have some kind of weird results, then it's really useful to go and inspect what is actually happening with those SQL statements, and you can copy and paste the statements from here and actually go and execute them manually against the SQL and see what do you need to change. So this gives you the logging capability. Then we spoke about the migrations already. A few more additional options you can do. You can do this, .NET EF database drop. So if you need to get rid of the database, which was already created and is there, you can tell to the system that, hey, please drop it. If you have enough access rights, then the database will be deleted. It's easier with the SQLite. You can just go and delete the file manually if you want to. It's not so easy with the full-blown SQL database. Maybe you don't have any kind of access into it directly, or you don't have the utility to access it. So then you can still use it from the command line like that. You can drop the table and start from the scratch. And as I told you, you can also execute the migration from the code. So executing this in the beginning of your database operations, or when your app is starting up, you can tell to the entity framework that, hey, please go and check the migrations. Is everything up to date? So are all the migrations updated, and is the database actually there? You can also delete the database from the code. If you write this myDbContext, so your DbContext instance .database and then you can see a bunch of methods there what you can actually do with the database. So there is such method as ensure deleted and stuff like that. So you can also kill the database from the code or start from the scratch every time your code is executing. So then this data access program that we don't have the joins out of the box somehow magically appearing, and we have quite a few different ways how to approach the data access. So how to deal with the navigation properties, how to get the related data. And there are a few methods or few approaches. So the eager, the explicit, and the lazy. So eager is kind of a recommended way. So you load all the data you need at once. So basically you write the one huge SQL statement with all the joins and get all the data. Then we have the explicit method. Explicit basically means that we split our SQL into several different sentences and execute them when we need to. So we first load the students, and then, or let's say we first load the grades without the students and without the homeworks, and then on the next statement we'll tell that, hey, please, into the grades also load the homework data, but don't load the student data, for example. So we can control it on the detail level. Also, we don't do it here explicitly. We don't do it here in this semester. We'll probably use it somewhere on the next semester. And then we have the lazy loading. Lazy loading is kind of magic. This gives you this kind of code writing that where is our program? So we go and try to write out the DB grade. Where is our grade? That when you try to go access this student here, somehow magically this student will appear without you doing anything. You can see from the queries, if you actually enable it, that the initial query stays the same, that only the grades are asked from the database and no students and no homeworks are included. And then when the system sees that, hey, you still try to access the student, then it automatically, lazily, so when it sees that you try to access it, then it writes a query for it itself and goes and loads the necessary object. This is a huge problem. So don't do it, and I will not even show you how to do it. It was long time missing. It was we debated about it for several years that maybe it shouldn't ever even be in the EF core. It is there in the full-blown entity framework, in the old entity framework 6. Now with the entity framework core 3.1, it was finally still added, but it's kind of like really, really bad practice to use it. So it's best even not to try. What it will do, you have to ask from your database guy that it will explain you to in detail, in depth, what is 1+n query problem. But even here with this simple grade, how many queries will be there against the database? So one query is to load all the grades, yeah? Then we start to write out the grades one by one. In every grade, we try to access the student and the homework. So for every row, for every grade object, we will create 2 additional queries to load the specific student and to load the specific homework. So basically, this is this 1+n query problem. We will create one query to get the initial data, the main entity we are working with, and then we will create, for every item, we will create n additional queries to load the rest of data. So this will be like huge load against your database. And if you actually try to do it somewhere where you work, then some DBA administrator will come and present you with a nice Azure invoice about database access. So you can stack up quite a huge invoice with that one. So we will create quite a few database queries. So don't try to do it even. So we will mostly use the eager data loading, so how to get the related data. And this looks like this. We have this special command for it, which is this include, and this is a join. So include, and it does join. And you can do several joins. So just include, and with this lambda syntax, you will point out what is the related entity, the navigation property you want to actually load. So the system can figure out what the SQL should be. You can do several joins. So we can, from the grade, we need to do grade to the student and grade to the homework. And even more, you can go into the depth of multiple levels. So from the grade include the homework, from the homework include, if there is something else, I don't know, subject maybe. So you can go into the depth with it. And the data is loaded correctly. And you can always jump back from here. You can jump back to the root level, just start with the dot include, and then you're back into the root level. And can include the next stuff. So let's fix our code to see that we actually can load the data. So it's here. Here is the query, db.create. So here is this include. What do we need to load? We want to load the student. And then also we want to load the grade. Student, the grade, homework, sorry, not the grade. So let's include this and include this. And maybe correct will be G as a grade. And now I execute it again. Let's see what the result is. And yes, now I have the full data. And if you look at the generated SQL, then we have two joins now defined. So inner join from students and the inner join to the homeworks. So two joins are additionally added based on those includes. And of course, if you dig around it, you can do all kinds of fancy stuff here. So for example, let's try to add here some more options. Where, let's say something, I don't know what. Where create dot grade ID, I know, is bigger than 2. And we need to define it, of course, correctly. No, that's not the good name. Let's put the G again. So you can write all kinds of where conditions and write your normal C# predicates here. Let's say and G dot grade ID is less than 5. And then maybe order by descending. with the grade ID. So let's run it now again. So now I get only 2 rows, 3 and 4, because those will be in between 2 and 5, and they order it in the other way. Pay attention how the system works. Where was the ordering done? Is it in memory or is it in database? Where was filtering done? Is it on memory or is it on the database? So was everything copied from the database to the memory and then sorted and limited in the memory? Yeah, of course not. So you can see here from the query where g.gradeID is bigger and it's less than 5 and order by descending. So this is the power of the ORM, the object relational mapper, that we just write our kind of C# methods and C# code, and behind the scenes it will be converted to the SQL or whatever the database engine is. So it's quite a powerful system. And the most kind of, not amazing, but let's say when you try to write more complex queries and do some fancy database operations or let's say fancy selects, then typically what Entity Framework is generating is better SQL than you can write manually. It takes quite a few years of heavy SQL experience when you try to write better SQL. Definitely doable. Not always is the Entity Framework perfect, but mostly Entity Framework generated SQL is really, really, really good, and it's really, really fast. So it tries to use all kinds of caching and keys and temporary tables and whatever else, so like fancy SQL tricks. So now a little bit the theory about the Entity Framework Core itself. So we spoke about it, that you always need the primary key. It's not actually true, not always, but for us it is true. And by the conventions, we have this syntax, class name plus ID, or then just ID. Both of those are okay. If you have some weird primary key name, which isn't according to the standard, then we need to help out the system a little bit. Then we have 2 ways how to actually help out the system. We have annotations. So annotations is this in square brackets. You will write key on top of the field. Or in the model builder, when you actually configure the system, you can do it in the Fluent API, so you can point out the syntax in the C#. If you want to use this composite key, we already spoke about it, that the grade theoretically can use composite key. Entity Framework supports, and SQL also definitely supports composite keys. So you can definitely do it, but the composite keys are only doable in the C# code, so you cannot do them with the attributes. So previously in the old Entity Framework, we could do almost everything with attributes, but now Entity Framework Core has taken the approach that attributes will be only used, or they will be only there if the attributes are used in several different places, in several different, let's say, subsystems. Not just by the Entity Framework, but maybe by the web or some kind of validation or whatever else. Then there is an attribute, and the Entity Framework will support this. But the Entity Framework specific attributes, for example, this composite key thingy, this was removed, and that one you have to do in the code. So there is the overload method model on model building. You need to overwrite in the DbContext. But we mostly can just use attributes. We don't do anything fancy like that. Then we now switched over to the nullables. So now we can mock around in the database what will happen with nullable fields. For example, if you make a string nullable, what will happen with that one? What will happen in the code and what will happen in the database? So we can force to the database that even if the code shows that the stuff is nullable, if I add the question mark to it, we can still tell to the database that, hey, don't use it, and go over to this attribute, or do it with this easy regard in the code. Sometimes really useful. One important thing is this attribute MaxLength. So this is kind of important, especially for the strings. So don't allow generation of database, or don't do a database where you can store unlimited string length into the database. This has cost me a lot of headache in my own servers, because somebody will figure out how to access the database directly, and then we'll just store 4 gigabytes of data on every record. And then I did run out of disk space, and then my server was dead, and then it was like humongous problem how to actually get my server back online. I couldn't just drop the database like that, because there was actual production data. And they didn't do it like fast, so that I had just like a limited range of records to delete. It was like spread over the month, slowly, just grow and grow and grow. So there was intermixed like normal data with bad data. So I had like huge problems. And even just to get the disks back online, because it was totally full, it didn't start it up anymore. So I need to move the write to the different server, start it up there as an external disk, and so it was like huge headache. So try to or be nice, and we will definitely check it on the defense that will limit your string lengths. So use this max length attribute on the strings. And one more thing which is really useful, typically not here in this course, you will do the typical developer approach that my database only has 6 records in it and everything works fast. But this will not, in reality, this will not work like so. And you definitely need to help out the entity framework, or not entity framework, but you need to help out the SQL how to index something. So the primary keys and foreign keys are automatically indexed. You don't need to touch those. But everything else, all the what you will try to use in the where clause, basically everything needs an index, and you cannot add the indexes via the annotations. You need to use this model builder. So this is how we add it, and we can do all kinds of like fancy, not fancy, but like standard index stuff. So first you can add an index. You can tell that the index has to be unique. So for example, that only this email is only allowed once and not more. So if as soon as there is already this field there, this value there in the database, don't let add another record with the same value. And we can also do the composite indexes, so more than one property. So then the syntax is this. You create a new anonymous object and point out the fields like this. And plus, of course, you can add this .isUnique at the end here. So you can do composite unique indexes. So we can fix this immediately. For example, we can say here in our code that this combination has to be unique. There only can be one address cover, and this is it. Or only one change bond and no more. So no other is allowed. So this we have to do with indexes. So where is our database? Here in the DAL. So let's say we have on something here. On deserialization, on server, where is all our own on methods? For me, there are. Protect that, override. On model grading, it automatically knows what I want to do. And here we can modify our stuff. So we want this entity student. Has index. Let's say entity as index I first name, I last name, and finally is unique. front like this. So this will create an index in the student table over the first name and last name and makes the combination unique. What do you think? Can I apply now migration? Why not?
You have duplicate rows already.
Yeah, I already have duplicate rows, so my migration will fail. So let's try to use the rest of the fancy commands we already learned. So now first I need to add a new migration. So it's not anymore the InitialCreate, so don't reuse the same name. Student index maybe. And now it warns us, hey, at least he thinks, or it thinks that this migration might do something bad with the data. So you are warned that please check what the hell is going on. But I think that, yeah, okay, I'm happy about it. Let's try to, and let's do the next thing. Let's try to do the migration in the code. So here we have the database instance. We can do the same thing here from the code. Apply all the new migrations. And let's run it. Let's see what will happen. Yeah, definitely we crashed. Applying migration. Yeah, okay. SQLite does not support this migration operation, alter column operation. We are totally stymied actually. SQLite actually doesn't allow changing of databases. You cannot modify existing columns. You can just recreate and copy data over and do stuff like that. So SQLite in some sense, not some sense, in quite a few senses, is actually very limited. So this will be the problem.
It's powerful at the same time.
So we need a better database. So let's find a better database. And I definitely have one for you somewhere. So I want to switch over now to the full-blown SQL Server. So this is the Microsoft SQL Server. Let's drop the SQLite for now, or basically forever. And let's use a server, but this has some problems. So the first problem is this: you need SQL Server. So you need to find a way. You need to find a way how to actually run a SQL Server. Different options how to do it. If you are on the Windows, you can run it locally. And then you can not install the full-blown SQL Server, just download the local DB, which is a one-person SQL Server, executing locally for in your own user rights. And I had that one on the slides, I think, how to use it. So here, this is the connection string for it. But the other option is use full-blown SQL Server. So if you are on the Mac or on the Linux, then you cannot run the local DB. This is only for the Windows. If you are on the Mac or on the Linux, you can run SQL Server natively. So there is a Linux version of the Microsoft SQL Server. The other option is, and the only option in the Mac is, you have to use a Docker. So you have to run SQL Server in the virtual machine. This is actually what I'm doing mostly. So I have my Docker instance, dashboard, and my Microsoft thingy is running. Microsoft SQL 2017 latest Ubuntu. But we will dig into it in the next semester. If you want to do it now, this is up to you. Go to figure out how to actually run the Docker and how to install Docker images and how to actually then execute them and run get the working container up and working. It's not anything complicated. Definitely you need it for the next semester. So if you don't have laptop enough or computer enough, then you need to deal with something and find a way where to actually run your code. We will need to do several Docker images on the next semester. So everything will be in the Dockers finally. And the other option is use SQLServer from somewhere, from service. Yes, if at all possible, then don't go to the Azure, not sooner than you need to. You get, as a student, you will get $100 credit, I think, from the Azure, and you can blow through it really, really fast without thinking about it. And then when you really need your Azure for the schoolwork, you're out of money. And then you need to kind of pay for the access.
You can have one free container also.
Yeah, that will work for like really, really limited time.
No, but if you start to load it again, then they boot it up.
Yeah.
So it takes, the first load might take 20 seconds or so, but after that it's fine. So if you're working with it, for a test environment.
For a test environment, you can run a free container, which has like heavy limits.
But there's one.
There's only one. And the limits are like this, that you get in 1 hour, I'm just speaking out of my head, the limit was like that in 1 hour you can access it for 15 minutes, and the longest time is like something, so it just stops. Yeah, we have used it a lot.
Oh, I didn't have any limits now.
We did hit limits. Maybe it's changed now, but it used to have limits previously. Long story short,
don't do it.
Don't do it. Don't overuse your Azure $100 credit before you need to. And I will provide you with the Microsoft SQL Server. So I have one running. Actually, I have several of those running, and I will give access to one. And I just need to dig it out from somewhere. Kas keegi mäletab enam, kus see on? Let me see. Mis oli Barreli info? Kus me tegime seda? Mingis demos? Ei, see kõik töötab, see on väga ilusti töötab kõik. Kas see oli siin kuskil või?
Ma annan sulle ka. Kuhu ma panen selle?
Viska sinna sammusessegi. Teamsi, see on kasutamis kõigile. Ei, see on paha, see on kinni pandud, mul siin ei ole Barrelit.
Panin. Siis järgi seda.
So we have this connection string for you. It's in the chat. So this is running in virtual machine in Docker here in school, in my system. So the server is this, and there is one thing missing from here, which is on the slides. No, it's not there. Then I need to take it from here. You also need this multiple active result sets true. This is also something you need for the SQL Server. Like this.
What's now where
What?
What was more needed there?
This multiple active result sets true. Let me just a second. I will put it as a better here. And oota, siin on veel midagi puudu, on ju. One more thing is missing from here, as you can see. We also need this. So this should be your student ID, and then not student ID. Oh yeah, uni ID. Uni ID, and then some kind of database name.
Logical, please.
And please use logical names. At least start with the uni ID. Your uni ID. Don't write uni ID there. I have so many problems with you guys that this is unbelievable. Especially this, that I will write my uni ID there or my name, and then you will just copy paste my code all over your projects, and suddenly everybody's using the same connection string as I'm using, and the databases just drop and go away and suddenly change the structure and nothing is working, and so it has caused a lot of confusion. So please create the unique database name for the project you're using, and start it with your username, with your uni ID. Without those smaller than, greater than. So for me it will be Andres.cover and then DbDemo, something like this maybe.
My absolute favorite is when mid-lecture you're doing an example and suddenly it's somebody dropped the database.
Yeah, absolutely.
Is the order important?
No, shouldn't be. Let's see, is it working? I have no idea, is the barrel still actually online? Should be. User ID, password should be this, database, yes, multiple active result sets. Now I need to delete all the migrations because my migrations are wrong. Those are generated with SQLite. So I need to start from the scratch. Because the migrations are dependent of the actual database server you're using. So now I can add them again. So this is now again the InitialCreate. Let's see, will it work? Or do I need anything additional? Yes, at least it created the migration. Now I can try to run the code. Let's see. Yes, it is working. Went okay. So the initial login took some time. Ei ole update'i, me tegime koodis seda. Mul on nüüd siin ju koodis on see migrate sees.
Already object name taken.
Because I have this here, DbDatabase this will automatically apply the migrations. So you can actually see how it goes here. Create table students, create table grades, so everything is done. So and we have this one special table which is called EF migrations history. This is where the entity framework is keeping track what version of database you're working on, what migrations are applied. But the rest of the tables are ours.
So the migrate method will add the migration and update as well.
Yeah. No, it will not add the migration. I mean, you still have to create the migration manually.
Yeah, no. I mean,
But it will apply the migration. It will check what is the latest applied, and then apply all the migrations.
Apply is the right word.
Applies all the migrations that are not yet applied. Since we only have one initial, then it basically creates the database for us. And now our migration went well. Let's see. No. Where is this? This is create. This is not it. Student first name. Execute that command. And you can see here this sentence. Create unique or index on student's first name, comma, last name. So we have this combo index over the first name and last name, and it's unique. So my first run went okay, and now if I try to run it again and insert a new student with the same name, it will crash. We got an exception, quite a lengthy one, but cannot insert duplicate k row in the object blah with unique index blah blah blah. The duplicate k value is Andres Käver. So I can't insert the second row with the same data into the database anymore. So since the first name last name will not be unique anymore.
So right now the tables were created on your server.
Yes, the tables are now somewhere.
So I messed something up, I get that table already exists. How do I delete it?
You can do this, we had it on the slides. You need to know the connection string has to be the same. It's based on the connection string, so don't change your connection string yet. And then we had it on the slides. Let's go back here. .NET EF database drop. So execute it from the command line. Or you can do this also.
In the code.
You can do it the same in the code. So you need still the same parameters, the --test project and the startup project. But you can do it from here also. db.database.ensure deleted. And then we need to do the migration after that. Because this will delete the database, then you need to recreate it. But it doesn't help with you, I think, because you already have some kind of wrong name there. But this ensure deleted gives you that you always start from the fresh copy, so everything is from scratch.
It worked.
So typically I don't delete from the code. Okay, in the full-blown web applications, we can have like nice configuration file with specification that migrate the database on the startup and delete the database and recreate it and whatever, insert some additional data and all kinds of like stuff. Here is kind of manual. So typically I drop the database manually. And if you really want to see what is going on, then don't use the rider. The rider, at least for me, the rider isn't the correct utility. And we have two options what to use. One is this, which is called Azure Data Studio. So this is Visual Studio Code based, or this kind of same system, based multi-platform database administrator utility for the Microsoft SQL servers. Actually, I think it can even connect wherever, but it has some specific Azure functionality and Azure whatever distributed support and stuff like that. But basically, you can manage your SQL servers. Just add a new connection from here. So I have this barrel here, and we can see all your fancy databases here. So let's say I can see them if I log in as a system administrator. So this barrel server, this is a full-blown Microsoft SQL server, but there are no guarantees. So if I get annoyed with you, I will just delete all the tables from here, or all the databases here, to clean it out. So don't use it as your production backend. So this is not the production service. Although you can for a while, but there are no guarantees. And you can see here my Andres Käver DbDemo. So I can see the tables, grades, check out the columns, keys. You can do all kinds of select top 1,000 rows. You'll get like nice stable output, stuff like that, so you can work with the data here. And the other option is do I have it even currently in the Windows? Is this? So this is the kind of the full-blown utility. Is this SQLServer Management Studio? So this is free. You can just download it from the Microsoft. But this works only in Windows. But this is the kind of the official client, so to speak, for the SQL Server.
It's pretty good.
It's pretty good. You can do everything here. So you can, but this only works in the Windows. So go figure. Actually, this Azure Data Studio is also does almost, I think, almost all the same things. Just a little bit different user interface. So this is about the migrations. Now you have the full-blown SQL Server. I recommend you I think I would recommend you to use the SQL Server. So if you want to run it locally, then install Docker if you are on the Linux or Mac, and then run it from the Docker, which I'm doing, if you need to do like local development. And if you have always the like network connection, then you of course can use the remote server, some kind of. So there's one, so the barrel is for you to use. So we had spoken about this, primary keys. So we should also do this, maximum length. So just now, if you look at the data, let's see the students, the columns. Oh, there is even some kind of limit now, nmarchar 450, go figure. Typically it used to be max length. But what would be the correct way how to do it is this. Max length, some kind of value, and now I need this max length from somewhere. Let's see, where is it? Is this system component model annotations? Now I can import it. And the same with the homework. This description should also be limited. Grade doesn't have anything, I think. Just an integer. Yeah, that's okay. And now, of course, once again, add migration. And let's run the code. Whoop. Something crazy. Oh, okay. Because I still try to insert the same stuff again. But now I should have the string lengths limited. Let's see, students, columns. Yep. Now they are nmarchar 128. So what I said with an attribute. So we did the indexes. You can also set up the default value. Sometimes useful. And you can also set has default value SQL. So then the SQL function is executed and the value is generated in the SQL. We can also say to some stuff, typically we don't need it, how to exclude properties. So if you have some data that should not be mapped into the database, then we can use this not mapped annotation. Then this property will not be added into the database. It's missing in the table. if it's somehow calculated, for example, automatically the getter only properties will not be created in the database. And we have some tricks with the relationships. So far we did this one-to-many, and everything worked kind of like automatically, and we didn't have any issues. And if there aren't any issues, if there is only one relationship, for example, from the student to the grade, for example, then everything works automatically. As soon as you do something like this, that there is twice this relation, then automatically Entity Framework will complain to you that, hey, I'm sorry, I cannot figure out which primary key and foreign key should now match with each other, and then we need to show up with those foreign key and inverse property, what is going where. And the same way, if your key, your foreign key, if the name is wrong somehow, it's not the property name plus ID. If you are using some kind of weird foreign key, then the same way as we add the primary key, the attribute key, we have the foreign key property to point out the correct foreign key. So for example, here's demo, how this would look like. So foreign key is used when the foreign key is not discovered. So here you can see that the field name is blog, so there should be a foreign key named blog ID, but it is something like this, weird, blog foreign key. So we need to use this syntax, this attribute, to point out that, hey, this field blog actually uses this integer as a foreign key. And then this inverse property, when you have several times the same relationship between entities, then the Entity Framework will complain that, hey, I cannot find out what the hell to do. And then we need to use this inverse property on top of the list, that, hey, this list actually should be put together from the author field and this list from the contributor field. So typically, at least I think in our current homework, you don't need this kind of issue, but if you try to test something or try to do something fancy, not really fancy, but like do some kind of like little bit more complex test with this ORM system, then you will hit those problems. So those are kind of like the most common configuration systems you need. And you can do the same navigation with the Fluent API in this on model creating. So there you can kind of work in real details. Kus mu kursor oleks? Katki. Kõik. Mis nüüd? Patarei sai tühjaks. Ei tohiks öelda, peaks mingi, ma ei tea, kui kaua töötama. Mis asja? Tund sai läbi vist küll, jah? Läbi ta... Mul veel 44 sekundit, ma tahan ruttu kõigega ära rääkida. Then one more thing, just for information. If you do not like this cascade delete, just now if I would delete the grade, for example, then the student and homework will go with it. So it automatically checks that the integrity has to stay there in the database. And it's enforced via the cascade delete. If you don't like it, then you can do this on the on model grading and just remove or set the cascade delete options to the restrict, for example. Then this will mean that you will just get an exceptions. When you try to delete something, but there are foreign keys pointing to it, and you cannot delete it, then the Entity Framework will throw an exception for you. So basically, then you have to manually